In this video, we're going to review graphing quadratic functions from Chapter 3. We're going to start by looking at functions in the form y equals ax squared. And we notice when we're looking at that form that nothing has been added or subtracted to our x. So our vertex is still at 0, 0. So for this graph, our vertex is at 0, 0. So we plot that right there. 0, 0 for the vertex. We know that the axis of symmetry is the vertical line that goes through the vertex. So that line has the equation x equals 0. Then we need to graph our other points. Here we see we have a vertical stretch by a factor of 2. So normally we would go over 1, up 1, over 2, up 4, and over 3, up 9. But because we have a vertical stretch by a factor of 2, we're going to multiply all of those ups by 2. So now we're going to go over 1 and up 2, over 2 and up 8, over 3 and up 18. So from the vertex, we go over 1 and up 2. I'm going to do that on both sides of the axis of symmetry. Over 2, up 8. Since that's all I can fit, I'm going to try to draw a smooth curve through those points. Put my arrows up on the end. Now once we've looked at this, we can answer some questions. We answered the vertex and the axis of symmetry. Now we want to talk about the domain. Well, the domain is all the possible values for x. And since this is a quadratic function, the domain is all real numbers. We can plug in any number for x. If I plug in 5 into that equation, I'm going to get a value. The range, however, that's the values for y, is not everything. For this one, we notice that we have a lowest point right here. So y only has values up here. There's no negative values for y on our graph. So our range is all y's greater than or equal to the y value at our vertex, which is 0. Then we want to talk about where is our graph increasing and where is it decreasing. So remember that you read graphs from left to right. So if we start on the left-hand side of this graph, we notice that as we move across, we are moving down until we get to the vertex. So for that part, it is decreasing. Well, what are the x values? Let's see. Let's move this. The x values for those, for this side of the graph, well, all of the x values over here, they're all negative. They're all less than 0. So that was where it was decreasing. So it's decreasing where x is less than 0. So let's get rid of that. Now we want to look at where it's increasing, and it's increasing on this half of the graph. So that's where our x's are greater than 0. You'll notice on the increasing and decreasing, neither one of those got an equal to 0. Where x is equal to 0, that's our vertex. That's where it's changing direction. So it's neither increasing nor decreasing at that point. Okay, let's look at the next one. We have y equals -1/2 x squared. So again, for this one, since there's no addition or subtraction, we know that our vertex is still at 0, 0. And since our axis of symmetry goes through that, our axis of symmetry is x equals 0. Now to graph it, we're going to look back at that basic shape, 1, 1, 2, 4, 3, 9. And this time we have a vertical shrink by a factor of 1/2. So times 1/2 is 1/2. 4 times 1/2 is 2, and 9 times 1/2 is 4.5. You'll also notice that a is negative, so we know that there's a reflection in the x-axis. So instead of going over 1 and up 1/2, we're going to go over 1 and down 1/2. So we're going to have a point here and a point here. Then we're going to go over 2 and down 2. And then for the last one, over 3 and down 4.5. And then we're going to draw our smooth curve through those points. Now we're going to talk about the domain again. We can plug in anything we want for an x value. So the domain is going to still be all real numbers. But the range, we notice for the range we have a highest point this time. Our vertex is a maximum. So the only place the graph exists is down here where the y values are negative. So let's see. Our range is y is less than or equal to 0 because that's the only place where the curve exists. It's increasing over here on this side. We're increasing on this half of the graph, and that half of the graph is where x is less than 0. Then we're decreasing on this half of the graph, and that's where x is positive, so x is greater than 0. So this is our graph when we're in the form y equals ax squared. We see that the vertex is always at 0, 0, and that the axis of symmetry is always at x equals 0. In the form that we learned next, we have ax squared plus c. This plus c we know changes where the vertex is. When there's no value of b, as in ax squared plus bx plus c, that's our standard form. When there is no bx, then our c just tells us a vertical translation. So this minus 4 tells us we're going to move 4 in the negative direction. So we're going to go down to 4 on the y-axis. Our line of symmetry is going to stay right there because it has to go through the vertex. So let's see, our vertex is at 0, negative 4, and our axis of symmetry is x equals 0. From our vertex, we look at the fact that we have a vertical stretch by a factor of 2, so we're going to do the same thing we did before. We start with our parent function shape, and we just multiply. Since this is a vertical stretch, we multiply all of our verticals by 2, so 2, 8, and 18. And then we're going to plot those from our vertex, over 1 up 2, over 2 up 8, and then that's all that's going to fit on our graph, so we can go ahead and sketch our curve. Once we have the graph, we can answer the other questions, domain and range, increasing and decreasing. So our domain is still all real numbers. Any value for x is going to have a value for y. And then we look at our vertex to find out what our lowest point is. That's where y is negative 4. And the graph only exists above that point. So the range is all y's greater than or equal to negative 4. Then we want to look at increasing and decreasing. We notice on the left-hand side that our value is decreasing. So it's decreasing where x is negative, x is less than 0. And then after the vertex, it's increasing in value. So it's increasing where x is greater than 0. All right, let's graph the next one. Y equals negative 1/2 x squared plus 1. So this plus 1 is our c. That's a vertical translation, 1 unit up. So our vertex is now up here at 0, 1. Our line of symmetry comes through there, so x equals 0. Now we're ready to graph it based on the shape. We see that it's a reflection because a is negative. We have a vertical shrink by a factor of 1/2. So we're going to take our shape and we're going to multiply by a factor of 1/2. We're going to plot our new points. Over 1, down 1/2. Over 2, down 2. And then over 3, down 1, 2, 3, 4, and 1/2. Remember, these are not ordered pairs that I'm plotting. This is just the shape based on where what the stretch or shrink is and based on where the vertex is. If you want to plug in values for x into this original equation up here, you can plug in values for x and get values for y, and those will give you these ordered pairs that we're plotting here. Okay, the domain of this graph, it's quadratic, so the domain is still all reals. The range, for this one we have a maximum, and our maximum is up here at 0, 1, and it's everything below that value of 1. So all of our y values are less than or equal to 1. As we read the graph from left to right, it is increasing until x gets to 0 at the vertex, and then it's decreasing where x is greater than 0. So it's increasing for x values that are less than 0, and it's decreasing where x is greater than 0.